Hello, my name is Professor Paul Catchings. I will be using 9 PowerPoint slides to present this presentation. Please take a look at the slide. And please look at the top where you see the name, the number, the name three-dimensional mathematics. Please look at and find the words Powerball, MegaMillions, and EuroMillions. Now please find the formula in the middle of n factorial divided by d factorial. This formula, when put in its three-dimensional state, bridges the gap between three-dimensional mathematics and lottery games. There is a new mathematics called three-dimensional mathematics, which must be presented to mathematicians and lottery players. Three-dimensional mathematics does not exist anywhere in the historical literature of mathematics. It did not exist in the time of Einstein, and it did not exist in the time of Newton. This new mathematics proves that calculations of the type n factorial divided by d factorial are in fact three-dimensional. Intractable problems of the type n factorial divided by d factorial are now solvable and predictive by groups. Embedded in these n factorial divided by d factorial calculations are groups of mathematically distinct odds which are applied to lottery games. Three-dimensional mathematics exposes these groups which otherwise would remain hidden from traditional sight. The hidden odds from n factorial divided by d factorial calculations for Powerball, MegaMillions, and EuroMillions are now available for lottery players. Any player using number sets derived from these n factorial divided by d factorial calculations now has 84% to 99% better opportunities to win the jackpot every 6 draws. By the end of this presentation, you will see doors of opportunity opening for lottery players, mathematicians, and scientists. This is really history in the making, and you're invited to be part of this history. Beyond lottery games, trillions and trillions and trillions of dollars are immediately at stake, making artificial intelligence obsolete. Let me repeat. Three-dimensional mathematics makes artificial intelligence obsolete. 100% of technology, 100% of business, 100% of science are about to be impacted. In chapter 3, on page 10 of the three-dimensional mathematics proof paper, on deposit with the USA Library of Congress, is a call for all mathematicians and scientists to state in the future that they are aware of 2 foundational facts because of this new three-dimensional mathematics. The first foundational fact is from the law of the conservation of energy, which states that one energy cannot be created nor destroyed. This comes from Julius Mayer's work in physics. The second foundational fact is the X, Y, and Z Cartesian coordinate system coming from the mathematics of René Descartes. These 2 facts, one energy and the 3 X, Y, Z geometrical dimensions, forms the foundation of all reality. Einstein used these 2 facts in his special and general theories of relativity. According to Professor Einstein, we have 4 dimensions. 1 dimension of time and 3 X, Y, Z dimensions of space. This 1 and 3 is where three-dimensional mathematics starts from. In the next slide, I will lay the foundation for exactly what three-dimensional mathematics is so that we know exactly how it is now possible for millions of lottery players to have 84% to 99% better odds of winning every 6 draws. Let me guide you through this important slide too. At the lower half of this slide are 3 panels, red, blue, and green, of information showing how three-dimensional mathematics brings 84% to 99% better odds to lottery players. At any time, you can visit 3dmath.com and download the PDF file of this presentation. The URL is at the top, 3dmathsecrets.com. In these red, blue, and green panels are mathematical proofs and empirical data from US Powerball. There are 21 rows of data in each panel because there are 21 groups of Powerball number sets. Without three-dimensional mathematics, this information would not exist. These 21 groups would remain hidden, and we would still believe that the odds of drawing any combination of numbers is the same across the board. But that is not true. With three-dimensional mathematics, we now have the proof. Let's start at the red panel, where it is proven that n factorial divided by d factorial calculations are three-dimensional, and that d number of groups of hidden order are embedded in these calculations. We use the 69 factorial divided by 5 factorial formula for Powerball. First of all, three-dimensional mathematics require 3 parts for the numerator, which for this example is 69. These 3 parts are 32, 23, and 14, as shown in the headings of columns 4, 5, and 6. In the red panel. Secondly, we need to know how many different ways in which the denominator of 5 can be split into 3 parts. Plug the number 5 into the formula at the bottom of the red panel and you will get 21. Here's the formula to find the numerator, the denominator. This is the number of ways in which the denominator of 5 is split up and arranged in 3 x, y, and z columns in the red panel. So there are 21 rows where the sum of x, y, and z in each row is 5. Now we have split up the numerator into 3 parts. We also have the denominator split up into 3 parts. So let's take one-dimensional n factorial divided by d factorial formula and express it three-dimensionally as 3-part numerator divided by 3-part denominator. This calculation is the essence of three-dimensional mathematics. Look at the red box above the red panel for the exact three-dimensional formula. Notice that we went from n factorial divided by d factorial, which is believed to be a one-way function, and now we have a three-dimensional formula to express n factorial divided by d factorial as a factorial divided by x factorial times b factorial divided by y factorial times c factorial divided by z factorial. We will apply this three-dimensional formula in each row for each one of the 21 groups. Let's start at the first row in the red panel. The three-dimensional factorial calculation results are 496, 253, and 14. We multiply these 3 numbers to get 1,756,832, which is the first number in the black column between red panel and blue panel. Now here comes the first mathematical proof. There are 21 numbers in this black column, all calculated from the three-dimensional formula. Adding up these 21 numbers gets you 11,238,513, which is exactly the same as 69 factorial divided by 5 factorial. Let me repeat. Adding up these 21 numbers gets you 11,238,513, which is exactly the same as 69 factorial divided by 5 factorial. Take 69 times 68 times 67 times 66 times 65, and then divide the results by 120, which is the product of 5 times 4 times 3 times 2 times 1. Since the sixth draw in Powerball game can have one of 26 values, we multiply the numbers in the black column by 26 to get the Powerball group size in the first column of the blue panel. The blue number in the first row is 45,677,632. Once again, we calculate for 21 rows in this column and add up to 21 numbers and get 292,201,338. The result is exactly the same number on the back of any Powerball play slip. If you like, again, visit 3dmathsecrets.com, download the presentation, and check the numbers for yourselves. Let's go to the next blue column. If you use number sets from group 1, your winnings are 1 in 45,677,632 instead of 1 in 292,201,338. That's an 84% improvement in your odds. We can predict how often a drawing will come from group 1 by dividing the total number of sets by group 1. Divide this number by the top number, and we can predict. We can predict how often a drawing will come from group 1 by dividing the total number of possible sets by the size of group 1. 292,201,338 divided by 45,577,632 is 6.4. This is how we predict the frequency of drawings from group 1. 6.4 draws in group 1 is rounded off to 6 draws for our prediction that a drawing will come from group 1 once every 6 draws on average. This statement is derived from three-dimensional mathematics. Similarly, statements are made for each group and placed in the middle column of the green panel. The last column in the green panel shows how many times a drawing comes from each group from October 7, 2015 through June 22, 2019. A total of 387 drawings have been made in this period between 3 and 4 years. As predicted, the largest number of drawings came from group 1. With such a strong correlation between group prediction and this 4-year history of Powerball drawings, it only makes sense that most of the 60 winnable number sets a customer get comes from group 1. The first column in the green panel shows that the customer gets 10 number sets from group 1, 8 number sets from group 2, 7 number sets from group 3. The total adds to 60 sets. Notice that in this group 17, 16, 19, 20, and 21, there are no sets allocated to buyers. The reason that there are no sets allocated to buyers is because statistically, these sets of numbers from these sets will rarely come or be drawn. For example, In the last 21st group, notice that in 387 draws, no winner came from this group. Notice that 1 came from the next one up, which is 20. 0 came from 19. This is the power of three-dimensional mathematics in operation. What you're witnessing with three-dimensional mathematics applied to the n factorial divided by d factorial formula, prior to three-dimensional mathematics, all textbooks, all numbers on the back of American Euro lottery game, given the odds. The formula is 69, or n factorial over factorial. This formula has never been put into a three-dimensional state until this presentation. Now we see the example of how to put n factorial divided by d factorial into its three-dimensional state. In other words, as long as we have n factorial divided by d factorial, we have the belief in probability, randomness, chaos. This only comes about because of the limitations of this formula, n factorial over d factorial. Now that we know the three parts of the numerator, we know the three parts of the denominator, we can now put the formula together and calculate and find that we have 21 hidden groups to this particular calculation. This is the first time in the history of mathematics that groups have been identified with an n factorial divided by d factorial calculation. In the next 3 slides, we will examine Powerball drawings into more detail to see why our customers get an edge. Okay, in the last slide, we used three-dimensional mathematics to predict that most numbers of draws come from group 1, 2, and 3, with one draw coming from group 1 for 6.4 draws, every 6.4 draws. We know that the highest frequency of draws come from group 1. Now let's look at the drawings from group 1 in a different way. In this slide, in the next 2 slides, we have compiled a list of events where consecutive draws coming from the same group. Please keep in mind that this is empirical data that came from 215 to 219. What are consecutive draws? Let's say on Wednesday a drawing comes from group 1 on Wednesday. Then another drawing comes from group 1 on the next drawing date, 3 days later, which is Saturday. In this example, we have 2 consecutive draws from group 1. Three-dimensional mathematics was used to analyze Powerball history of draws from October 2015 through June 2019. During this 4-year period, it was discovered that there were 12 events, consecutive draws coming from group 1. There were 6 events of consecutive draws coming from group 2. In this same period, there were no more than 3 events from any one of the groups. Note that the 4 shaded areas, again in the last column, those shaded areas show 4 events when consecutive draws came from group 1. Let's go to the next slide. Here we can see 5 events when consecutive draws come from group 1. Normally, there are just 2 consecutive draws in these events. But in 2 of these events, we see 3 consecutive draws coming from group 1. We're now looking at table 3. I just passed table 2 because it's pretty redundant. Please take note of the following point, especially if you play lottery games. Each lottery game is a system of number combinations. The proof of 21 group behavior in Powerball, MegaMillions, and EuroMillions comes from the application of three-dimensional mathematics to these systems of numbers. Furthermore, the three-dimensional mathematics is applied to a much, much larger system of numbers, where an answer to one of the 7 most important mathematical problems has been sought for decades. This slide is the front cover of the proof paper for three-dimensional mathematics. Use the problem called P equal NP problem solve. P versus NP, or P equal NP, for mathematicians, particularly number theorists, are aware that this is one of the 7th most difficult problems in mathematics to solve. This problem is solved with three-dimensional mathematics as we presented in this presentation. My research paper, P equals NP problem solved, provides an answer to P versus NP question. The answer is verifiable using zero knowledge proof protocol. This 31-page research paper is registered at the U.S. Library of Congress.